Up until this point, we've been dealing with natural radioactive decay, a process that happens all by itself without any human intervention at all. But now it's time to look at human ingenuity and how we've been able to put this to use to create brand new elements that may not exist anywhere else in the universe, and our ability to expand the periodic table past the 92 naturally occurring elements that we've known about. This is topic 4.05: Artificial Transmutation. Oh, yeah. Now, here's the difference between the two different kinds of radioactivity. First of all, we have natural decay, and then we have artificial transmutation. I think the words natural and artificial kind of speak for themselves. They're also called natural radioactivity and artificial radioactivity. Natural decay happens all on its own. We don't have to do anything to make it happen, it just happens by itself. Whereas artificial transmutation doesn't happen without people. Natural decay has one particle on the left and two on the right. A parent nuclide turns into a daughter nuclide by releasing a decay particle. Artificial transmutation takes an original element, shoots it with a particle bullet, turns it into a new element, and a fragment is given off along with it. Notice two things on the left and two things on the right. This makes it a little easier to see. You see, in natural decay, one element turns into another by releasing, a decay particle, whereas the other will not turn into a new element unless you hit it with something first. So this is the natural beta decay of carbon-14 into nitrogen-17, and this is the artificial transmutation of plutonium-239 into curium-242 by bombarding it with an alpha particle. You see, plutonium-239 will not naturally turn into curium-242. It requires human intervention by whacking it with a particle bullet. Now, of course, a bullet implies a gun, and we'll talk about that in a moment. So this natural decay will naturally produce new elements, whereas artificial transmutation will deliberately make new elements. Now, here's how it happens. Let's take, for example, this nucleus of boron-10. It has 5 protons and 5 neutrons. This nucleus is stable, and it will remain the way it is pretty much forever. Unless, of course, people get their hands on it and put it in a particle accelerator and bombard it with a bombarding particle, which is, in this particular case, an alpha particle. The boron-10 is perfectly happy to remain as it is, but if you hit it hard enough with an alpha particle, then what's going to happen is it's going to absorb that alpha particle and become unstable. Nitrogen 13 and a neutron. So that is artificial transmutation, turning one element into another by whacking it with a particle bullet. So this is the original element, this is the bullet, this is the new element, and this is the fragment. Okay. So that would be the final equation, how you would read it. And notice that there are two things on the left and two things on the right. We will get these particles to hit each other by using a gun, a particle accelerator, which uses electric charge to accelerate particles and magnetic fields to hold them in place as they move faster and faster and faster until the particles collide. Any particle that doesn't have an electric charge, like a neutron or a gamma ray, cannot be accelerated in a particle accelerator. Well, gamma rays can't be accelerated anyway because they're made of light, and light's already going as fast as you can theoretically go. So how do you predict what's made during this artificial transmutation? It's actually pretty easy. So what you're going to have to do here is identify the mystery particle, its atomic mass number, its atomic number, and the symbol of whatever you've created. So what we do is we have to make sure the numbers on the top on both sides add up to the same thing, and the numbers on the bottoms of both sides add up to the same thing. Really easy. For example, 14 plus 4 is 18. So we need it to equal 18 on the other side. Now we have 17 on the other side. 17 plus what is 18? 1. So our mystery particle has a mass of 1. If we look at the bottom, 7 plus 2 is 9. On the other side, we have 8. 8 plus what is 9? Well, again, 1. So, what particle has a mass number of 1 and a charge of 1? Well, we go to table O to look it up, and 1 over 1 would be a proton. You could write H or P, doesn't matter which one you choose. That would be the identity of your mystery particle. So let's try another. By the way, both of these were the first the artificial transmutations carried out by none other than our dashing New Zealander, Ernest Rutherford. You know, the guy who discovered the alpha particle, the one who used the alpha particle to determine what the electric charge is, the one who's going to use the alpha particle to probe the innermost secrets of the atom, and the guy who whacked stable nuclei with alpha particles to turn them into new elements. This guy really liked to play around with his alpha particles. Anyway, let's look at the top left. 27 plus 4 is 31. On the other side, we have 1. So what plus 1 is 31? Well, that's pretty obvious. On the left side bottom, we have 13 plus 2, which is 15. We have 0 on the right side. What plus 0 is 15? Well, that's even more obvious. So, what is element 15? We look that up and we see that it's phosphorus, and therefore that is our mystery particle, 30 over 15p. Let's try another one. On the left side top, we have 239 plus 4. This adds up to 243. We have 242 on the other side. What do we have to add to that to make 243? Just 1. On the bottom left-hand side, 94 plus 2 is 96. We already have 96 on the right side, so we don't have to add any more. So what has a mass number of 1 with no charge? Well, that would be a neutron, 1 over 0 n. And so that is the mystery particle. One more example. Do you see this 4 in front? Well, that means there are 4 neutrons, which means the total mass is 4, and the total charge is still 0, because 4 times 0 is 0. So it'd be sort of like saying 1 over 0 n plus 1 over 0 n plus 1 over 0 n plus 1 over 0 n would have 4 neutrons. So on the left side, we have 249 plus 12, which adds up to 261. And on the right side, we have 4 times 1, which is 4. So what plus 4 is 261? 257. On the bottom left, we have 98 plus 6. This adds up to 104. Now, on the right side, we have 4 times 0, which is still 0. So what plus 0 is 104? Well, 104. What is element 104? Well, that is Rutherfordium, named for the guy who invented artificial transmutation. And I can say invented here because this had never been done before. It's artificial. So Rutherfordium 257, appropriate to name it after the person who discovered it. That is how artificial transmutation is done. I told you this was going to be easy. Next topic will be nuclear power. I hope you join us next time, and until then, keep well and bye.